And in the circuit breaker, we have a client which sends a request to, say, microservice A, and it gets a response from a remote service through your REST template, and then aggregates this and sends it to client, right? What if this goes down, right? The circuit breaker has to handle this. Hold on, I said circuit breaker. From where you brought up this word circuit breaker? Guys, circuit breaker is a design pattern. This is not enough explanation. It doesn't make sense. And give us some real kind sense of world. So that is where I'm going, to show you a real kind of sense of what I'm going to do. Let's go here and find out what I'm talking about.
The first uses a bimetallic strip.
Let's study about
a bimetallic strip consists of two strips of metal bonded together. As the temperature of the strip increases, the metals expand at different rates, causing the strip to bend. This bending upon heating can be used to make or break contacts in an overload device. In the diagram shown, an electric heater in series with the winding of a motor generates heat in proportion to the current flowing through the motor. If the current increases, the heater generates more heat. The bimetallic strip bends and opens the contacts, which trips out or stops the motor.
There you go. This is the way your motor is protected, right? Let's listen for that.
Motor.
So this is one
so
of
that is the way a motor is protected.
So this is one of the ways to protect your motor. Let's see one more, which talks about a circuit breaker.
So team, today we are going to study about circuit. Let's start on this.
Hi guys, my name is Bill, and in this video I'm going to show you what causes a circuit breaker in your electrical panel to trip and how to troubleshoot it. Okay, so what is a circuit breaker? Well, in simple terms, it's a device in your electrical panel that's designed to trip or break the circuit when it's overloaded. In this video, I'm just going to be covering single pole breakers, like your standard single pole, not an AFCI or a GFCI breaker. I'll cover those in a future video. So what actually causes it to trip? Well, I think the number one most common reason is obviously overloading the circuit. By plugging too many things in that draw too many amps of power, and the breaker's designed to trip. Now, if your breaker's rated at 20 amps, it's only designed to run at 80% of its rating continuously. So a 20 amp breaker is only capable of running 16 amps for a long period of time. It can handle up to 20 amps for a very short period of time, but the breaker will build up too much heat inside and then the bimetal will trip it off. The number two most common reason is, let's say you're hanging a picture on the wall and you run a screw through your drywall and you hit an electrical wire that was behind it. So you'd have a short in the wiring and that will cause your breaker to trip. Or let's say you're using an extension cord that has some sort of damage, like maybe you were outside and you were trimming your hedges and your hedge trimmer got your extension cord. That's what happened to me.
So now you got the reason of.
So this is about circuit breaker. Now we'll go to the application about Zoom. That means we're going to have a look at the actual application, which we are going to work on. And we will study the circuit breaker mechanism here. First of all, you can download the Spring Boot, Spring Initializer. Just go here and then you can say add dependencies and then search for asterisk circuit breaker and then add it, and then you just generate your zip file. Import this, which I already imported inside my demo. And what I have done here is that I have a Spring Boot class, which is having a circuit breaker here. This annotation tells Spring Boot that you have to look for circuit breaker related annotations in the beans which I'm going to auto wire. So that's the first thing you do in enable circuit breaker, and then you write a method where you specifically say that if I don't get a normal response, then fallback. That means trip the circuit breaker if I don't get a response. So when you trip the circuit breaker, you are actually protecting a client from, or your microservice from overrunning, right? Or running with the issue in network. Like for example, you might go to a remote service, but what if your network is having an issue, right? You will not get a response. So during that time, you need to have a standby method. So here my standby method is test fallback. This condition is exactly similar to what the circuit breaker has been told in the first two videos, what I showed you. And that's what I was trying to show in the whiteboard to you, right? That the circuit breaker is not able to open now. The circuit breaker is open. It has cut the circuit. There's no response. But when the circuit is cut, or the circuit breaker has cut the circuit, like we cut off the power supply to motor in the first video. The second video, he was showing how your home is protected when a short circuit happens. So take the same analogy now and think that your motor is not getting a power supply. So your motor is not getting a power supply. You are not getting a response from your remote URL. What would you do? You need to have a standby, right? So this is what the test fallback. It will come to test fallback, and then it will say product not found. And what happens is that when the client hits again, right, when the URL is up, he will get the response. This is in a very simple way to understand the Spring Break historics pattern, design pattern for resiliency. So let's try to run this. What did I do? I wrote a Spring Boot application. I made an enable circuit breaker. I have a REST controller. I have a Spring Boot application. I have auto-wired a fallback. And then I have request mapping and response body. And then what I'm doing is in my REST controller, I have a part test systrix. That means when I hit test systrix, I'm supposed to get a read product details response. This is my method from which I get read product details. This is the method I written read product details. So I put some sys out just for troubleshooting, in case there is any issue. Now, what I'm going to do is that I hooked up a remote service which gives me some details like DNA and all. And what I'm going to do is that when a normal response is there, I told you normal response is there. They should give me output. So what is the normal response? I hit test asterisk, then I should get a normal response. So let's start this and see. The method is starting now. And then what we are going to do is that after we start our Spring Boot controller, we are going to hit the local host here. And then in the local host, we have test asterisk. We got a response as soon as you hit test asterisk, right? So this is the JSON response. Did the circuit breaker come into picture? No, because everything is normal. Let's do something, so that things are not normal. How do you do that? You go to your fallback method. Let's play around. Let's give a fictitious URL. Say I say 1, right? And then what we do is that we rerun this. And then let's see what happens now. What is that we did something, which will cause problem? We have given a fictitious URL. This URL is not valid. How do we say this URL is not valid? Let's see. And then, yeah, there is no response, right? So we started this now. Let's go to localhost 0. So we were getting a normal response, right? This is the response when we are hitting test asterisk. But now you saw in the code that we have renamed the URL, right, to a fictitious URL. What was the fictitious URL? The URL which does not exist, right? So the URL which does not exist is here. This is the URL which does not exist. Let's see what's the response. There you go. So it has done a fallback here. The fallback here is to this method, because I'm specifying in the fallback as a historics command test fallback. That's why it is showing me product not found. So that's it about the design pattern for resiliency for microservices. Please do give me comments on this. It would be, great if somebody gives me a feedback, on this. And if I will come up with some more videos if you like this video.